Hello everyone, and welcome to Ingenious Nature, our new YouTube channel that explores the extraordinary ingenuity inherent in nature and how it has inspired countless human innovations. We humans, one of the most fragile of all species, have survived and thrived over thousands of years by relying on our intelligence, resourcefulness, and sometimes cunning. But more often than not, we have taken cues from nature's own creativity and imagination, sometimes even copying it outright. This is biomimicry, the process of learning from and mimicking the strategies and solutions found in nature to solve challenges that humans face in the design and application of techniques that makes lives easier. Today, in our very first video, we explore the ingenuity of termites, also known as white ants, in building their mounds. Without access to any engineering design or modern construction methods, these tiny creatures build massive mounds from earth, feces, and decaying plant matter. And despite external fluctuations, these natural structures maintain a constant temperature inside. This marvel of natural engineering has inspired passive cooling systems in modern architecture. Termite mounds are one of nature's most remarkable architectural achievements. These mounds, some reaching heights of up to 30 feet, house termite colonies that can number in the millions. The most fascinating aspect of these mounds is their ability to maintain a stable internal environment. Despite the extreme heat of the day and the cool temperatures at night, the interior of the mound stays relatively constant, around 86 degrees Fahrenheit or 30 degrees Celsius. This stable ambience is crucial for the survival of the termite colony and their fungus gardens, which they rely on for food. But how exactly do termites achieve this natural air conditioning? The answer lies in the sophisticated design of their mounds. They are equipped with a network of tunnels and vents, which facilitate airflow in a way that cools the interior. Warm air from the nest in the lower part of the mound rises through a central chimney and is expelled through vents at the top. Meanwhile, cooler air is drawn in through lower vents, creating a continuous circulation of air. This process, known as thermoregulation, ensures that temperature and humidity levels within the mound remain almost constant. Architects and engineers have long been fascinated by this natural cooling system and have sought to replicate it in modern buildings, and they have been successful. One of the most notable examples is the Eastgate Center in Harare, Zimbabwe. Designed by architect Mick Pierce in collaboration with Arup engineers, the Eastgate Center uses a ventilation system inspired by termite mounds. The building's design allows it to stay cool without conventional air conditioning, reducing its energy consumption by up to 90% compared to similar buildings. The Eastgate Center in Harare is probably the first building in the world to use natural cooling to this level of sophistication. It opened in 1996 with 5,600 square meters of retail space, 26,000 square meters of office space, and parking for 450 cars. The Eastgate Center's design is a deliberate move away from the big glass block, which are expensive to maintain at comfortable temperatures by using typical and conventional heating and cooling technologies. Instead, its structure is such that the air conditioning system works by drawing in cool air from the outside through a series of vents located at the base of the building. This air is then channeled through hollow spaces in the floors and walls, where it absorbs heat from the building's interior. The warm air rises and is expelled through vents at the top of the building, creating a natural airflow, occasionally assisted by fans, that cools the entire structure. This system not only reduces energy costs, but also minimizes the building's carbon footprint, making it a model of sustainable architecture. Termite mounds are just one example of how nature can inspire sustainable design. Biomimicry has led to a host of innovative solutions in architecture and engineering. For instance, the Beijing National Stadium, also known as the Bird's Nest, was inspired by the interwoven branches of a bird's nest. The stadium's lattice structure provides strength and stability while using less material than traditional designs. Similarly, The Eden Project in Cornwall, England, features biomes inspired by soap bubbles, creating large, light-filled spaces with minimal structural support. As we face the challenges of climate change and resource depletion, biomimicry offers a promising path forward. By learning from nature's time-tested solutions, we can develop sustainable technologies that reduce our environmental impact. Imagine entire cities where buildings self-regulate their temperature like termite mounds, where water is harvested from the air like desert beetles, and where structures are as resilient and as adaptable as coral reefs. The possibilities are endless, and the potential benefits are enormous. The ingenuity of nature holds countless secrets waiting to be discovered and applied to human innovation. If you enjoyed learning about this incredible example of biomimicry, make sure to subscribe and stay tuned for more amazing insights into the genius of nature. Share your thoughts in the comments below and let us know what natural wonder you'd like us to explore next. Thanks for watching, and we'll see you in the next video.